Hey guys, it's Eric again, and in this video I will be talking about debugging because debugging is hard, and in my experience, it only gets better if you do it more. So today I'm going to be doing an example of a bugged C program, and hopefully that will help you maybe gain some strategies or get some more experience in how to debug and fix your programs using GDB. Which is nice. Print statements only take you so far. Yeah. For this C program, we just have a bug C program. It's a pretty simple program. The only thing it does is it creates a 2D array, and then it uses a for loop to set each element of the 2D array to a newly allocated 1D array, and then it sets each element in that 1D array to a value. For this value, we should see 0, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, and so on for 15 rows. And then we print this array, so then we can see it, and then we just deallocate it. And that's our entire program. Not very complicated, and it looks pretty harmless, but if we build this, and then we run it, we will see that something strange happens. First of all, we notice that there's a double free or corruption message, and also the application has crashed. And if we look at our output, we do not see 0, 1, 2, 3, 4, 5. We see some very large number, 21,959, another very large number, 21,959, and then another very large number, which is certainly not what we wrote into here. Obviously, we're going to have to open our debugger. One thing that I like to do, just as a simple first step, is simply just to run the program and see what line or what symbol it crashes on. But unfortunately, it seems that we are in some function that is pretty deep in the Linux source code, which is obviously not something that we really know too much about. So we don't actually want to be looking at this. Um, but we can do some other techniques that will hopefully help us with this. So the first thing that I like to do is typically if I have a malloc block that I'm somehow not writing to correctly or the values inside of it are wrong, I like to change it to calloc, and that way when I receive the pointer, we will end up with a very regular 0. Every single thing inside of this block will simply be a 0, which is obviously nice because when we debug it, we will have some idea of what is happening that we're writing out of bounds to because we see the corruption, and so we just need to fix it. And so the thing that I'd like to do next is run it. And so I want to set a conditional breakpoint at this location, and then also at this location, because both of these places before the line should have a value of 0, and that should be a regular value. And the nice thing about GDB is we can have conditional breakpoints, as I said. So I'm just going to step through until I get to the line that I want, and then we can break at line 25 if the array 2D at the row is the value is not equal to 0. And we know that array 2D at the row should equal 0 because we use calloc to allocate an array that is all zeros. So we can see it follows it here. And then I want to step in to this one. And then I want to break at line 28 if the array 2D at row at column is also not equal to 0, because if we print this, we will also get a 0 because we use calloc, and that sets everything to 0, which is what we want, as I said before. So now we're just going to run our program. Oh, actually, no, we're not going to run our program. We're going to continue our program, and we can see that we've hit a breakpoint, which is not good because we wanted our array to be all zeros. And if something isn't 0, then something has gone horribly wrong. And we can see that the array at the index is 21, which is not 0. And if we print our row, we can see that we're still in bounds. We're in row 9 when we have 15 rows. And so that should be relatively defined behavior. So clearly something's up. And if we think about it, this probably means that our array is not the right size. So if we take a careful look at our calloc statement, we can see that we are allocating the size of an integer with this number of rows, which is exactly what we want. So we should be looking at this size specifically. And if we think about it, a 2D array is simply an array of 1D arrays, and each 1D array has type of int pointer. And so from this, we can conclude that we are not passing the right pointer to calloc or malloc. We are passing it the size of an integer when a 2D array is actually created of int pointers, not ints. And once we observe this, oops, I'm in caps, and we recompile it and we run it, we will see that it prints perfectly. So yeah, that's about it. I hope this helped you a little bit with conditional breakpoints, printing variables, uh, finding out how to start, things like that. And yeah, so I hope this helped you with getting a bit more familiar with debugging.